Alright students, welcome back to another section on math. And today we are going to look at general angles and radians. So, general angle is said to have its initial ray on the x-axis. So remember that an angle is composed of two rays that intersect at one point. Okay, so if the first ray lies on the x-axis, we call this the initial side, and it's always going counterclockwise. The side here is the terminal side. Terminal means it's the end. Okay, so this is called standard position. And that's again when the initial side is on the x-axis and it's rotating counterclockwise. So if I have this, I would say it's about 50 degrees. I could have another angle that is 120 degrees. So 120 would be something like this. Again, initial side is on the x-axis and it's rotating clockwise. So this angle here is 120 degrees and so on. Sometimes you may have a negative angle, like negative 45 degrees. What this is really implying is that, well, you still have the initial side on the x-axis, except this time, so here's the initial side. This time it's not going counterclockwise, it's going clockwise. So we can say that this right here is negative 45 degrees. And it's, again, this symbol here just tells you what direction the angle is going. Okay, so clockwise positive, or excuse me, counterclockwise is going to be a positive angle. If it's negative, it's going clockwise. So keep that in mind. Since we're talking about angles, there is a few ways that we can refer to angles. Angles, we can refer to them either in degrees, which that's all we've done in this class, degrees, right? Or in radians. There's two ways. Radians. And they both refer to the angles. It's like measuring distance in meters or in feet, still measuring the same thing. So let's say that I have 90 degrees. 90 degrees in radians is equal to pi over 2 radians. If I double this, I get 180. That's 1 pi radians. If I go 270, I have pi over 2 radians. And if I keep going, if I go to 360 degrees, I end up with 2 pi radians. You may be asking whether there's a formula that we can utilize to convert degrees to radians, and there is. To go from degrees to radians, all we have to do is multiply. So multiply times pi over 180. Okay, that's the short, simple formula. What if I want to go from radians to degrees? Well, you multiply times 180 over pi. Okay, so you can go convert from 360 to 2 pi radians simply by multiplying by pi over 80, or you can go from 2 pi radians to 360 by multiplying by 180 over pi. And that's basically the fastest way you can do that. Let's do one example. So let's say that I have, let's do, again, 360 degrees. I'm going to convert it to radians. So to do that, I use this formula up here. Multiply times pi over 180 recall that when you multiply fractions, you can go straight across if you want to, or you can look for those shortcuts. Let's just go straight across for now. 360 times pi, 360 pi, 1 times 180, that's 180. 360 over 180, well, that is just 2. Don't forget the pi. So, 2 pi radians is equal to 360 degrees. All right, so let's take this and let's apply it to more conversions. So, let's say that I have my plane here, the Cartesian plane. I'm going to make this somewhat big. All right, so this is the x-axis and the y. So let's say that I have an angle that is 0 degrees. Well, an angle of 0 degrees is going to be right there. 0 degrees, it's also equal to 0 radians, or 0 pi radians. 0 pi radians. But let's say now that I have another angle. Let's say I have 30 degrees. This is 30. 30 degrees, if I multiply times pi over 180, I get pi over 6 radians. Let's say that I have another angle. This is 45 degrees. Let's say it's 45 degrees. So this angle here is 45. If I multiply times pi over 180, I end up with pi over 4 radians. Okay, let's say I have another angle. This angle is 60 degrees. So 60 degrees, 60 degrees. If I have 60 degrees, if I multiply times pi over 180, I end up with pi over 3 radians. What if I have another angle that is, that's a bad line right there. Go back. Let's say that I have this angle here, which we know it's 90 degrees. Well, 90 degrees times pi over 180 is equal to pi over 2 radians. So I can keep doing this all over, but there's a short way, a shortcut in which I can obtain those numbers. So, if you guys remember these 4 right here, 30, 45, 60, 90, and remember the radians, we can figure out the rest of them, because everything else will be a multiple of 30, a multiple of 45, a multiple of 60. For example, let's take 60 degrees. 60 degrees. We know that 60 degrees is equal to pi over 3 radians. If I take 60 degrees, multiply it times 2, I end up with 120 degrees. This is this angle here, 120. 120, since I multiply 60 times 2 to get 120, I have to multiply pi over 3 times 2. And that will give me 2 pi over 3. Let's take this one here. 45 times 2 is 90. I already have that. But how about 45? 45 times 3. Well, that's going to give me 135 degrees. 135 degrees, which is this angle here. And since I multiply times 3, pi over 4 times 3, that's equal to 3 pi over 4. I can keep going. If I take, for example, 30 degrees, 30 degrees times 6, I get 180 degrees. So you have to multiply pi over 6 times 6, and you get 6 pi over 6, which it's equal to just pi radians. So we can keep doing this all the way around. I can have this one here. Let's do 30 times 7. 30 times 7 is 210. 210 degrees, so pi over 6 times 7, 7 over 6 pi. I can keep doing this all the way around until I get back to 360 degrees. 360 degrees, by the way, 360 will be coterminal. That means that it's going to be coinciding with the 0 degree line. So 360 degrees is coterminal with 0 degree, and that's equal to 2 pi. We can do 350 degrees. 30 times 7 is 350, so we get 7 pi 6. 60 times 5 is 300. 60 times 5 is 300, so 5 pi over 3, and so on. This right here, ladies and gentlemen, it's called the unit circle. This is going to appear again in this unit as well as in other classes like pre-calc or even calc 1. All right. The key here is to remember these four, as well as the radians, and everything else will be a multiple of those four. Next week we'll be adding more to this. We'll have other coordinates that are related to each degree and angle, but that's next week. All right? Please let me know if you have any questions. Otherwise, I will see you later. Take care. Bye.